This video will cover problem 9.11 from Gapenski's Healthcare Finance, 6th edition. Okay, so 9.11 is kind of a repeat of 9.6, and they're just using a slightly different language. But basically we have a uneven cash flow, $1,000 initial investment, and then 5 cash flow periods, 3, 4, 5, 0, 1, 2, 3, 4, 5, and we have 1,000, we have 250, 400, 500, 600, and 600, right? And so the first question is, what is the return expected on this investment measured in dollar terms if the opportunity cost rate is 10%? Okay, so basically what they're asking is, what's the net present value? And so we know the net present value is equal to the present value of the cash flows minus the investment. So in this case, so we would have to figure out what is the present value of these brought back here, right? That would be the present value of the cash flows minus the investment would be the $1,000. So we've got to figure out what's the present value of these cash flows. So I'm going to go ahead and just use the cash flow calculator first. You clear it. So cash flow at time 0 is 1,000 negative. Then I get 250. I only get it once, so then I have 400. Cash flow 3 is 500. Cash flow 4 is 600. And I get that twice. I get it here and here. So then I go to the NPV. NPV I is 10. The discount rate is 10. And just hit compute, and I get 715. So what is this telling me? Well, it's giving me the whole answer, which is 716. In order for me to kind of plug that back in, what I need to do is add $1,000 back. So it's really 1716 minus 1,000 gives me 716. So this does that minus, does this the cash flow register when you calculate NPV, does this calculation automatically for you. You can muscle through this problem calculating the present value of each of them. So that would look like 250 divided by 1.1, 400 divided by 1.1 squared, 500 divided by 1.1 cubed, 600 divided by 1.1 to the fourth, and 600 divided by 1.1 to the fifth. Why? Because the present value equals the future value divided by 1 plus the interest rate raised to the n, right? So let's go with this last one because we've done this a bunch of times already. But 600 is the future value. The interest rate is 10%, so 600 divided by 1 plus 10%, 1.1, raised to the 5th power, right, gives us each of these. Let me pause here and I'll fill that. So if you run the calculations for each of these, this is what you'd come up with, and then it would add up to 1716, and then you would have to subtract 1,000, and you would get 716. So that's part A. All right, part B asks you to kind of explain in your own words, what this net present value of $716 means. So net present value is kind of a hard concept to wrap your head around, just mainly because of the present value piece of it. But basically, you're looking at you're comparing the economic cost of the investment against the economic value of those future cash flows, the future resources that are coming to you as a result of the investment that you're making. So a net present value of 0 means that the economic value of the future cash flows, when they're discounted uh, uh, for the opportunity cost, in this case 10%, back to the present, a net present value of 0 means that you are basically just indifferent to doing the investment. You are, in this case, you would be getting $1,000 worth of future value in exchange for a $1,000 investment. That's what a net present value of 0 would mean. A positive net present value means that the future economic value of those future cash flows is actually worth more than the investment that you're making. And then a negative NPV would mean that the future values of those cash flows, the present value of those future cash flows is worth less than the money it would take to generate them based on the discount rate that you're applying, in this case 10%. So you shouldn't do that investment because you're essentially destroying economic value. All right, part C says, what is the return on this investment measured in percentage terms? Well, lucky for me, the cash flow register on the BA2 Plus, so I have it already programmed in. I can just hit the IRR button and hit compute, and I get 31.25%. So that means that if I were to make this investment, the fact that it cost me $1,000 to make the investment and I get back 1716, I'm going to make a 31% return on my investment. That's a pretty significant return. And so that's that's how you get the return in percent terms. You could do this on a spreadsheet. There's an IRR function on Excel. There's not really a quick way to estimate that percent return in another way other than using a spreadsheet or using the cash flow register. So we'll leave it there for problem C. You're going to need one of those two tools to do this problem. And then finally, question D is, should this investment be made? Well, if the appropriate opportunity cost is 10%, then the NPV, you have a positive NPV, so that tells you, yes, you should do it, because the investment rule is do the investment if the NPV is greater than 0. The other investment rule uses the IRR. So if the IRR, the percent return that we just discussed, is greater than the discount rate, I, that we're using, right? So in this case, we said it was 31.25 is greater than 10%. So yes, you should do the investment. And they're always going to, the NPV and the IRR are both going to tell you the same yes or no. There are some nuances between the two processes, but they both give you ultimately the same, or at least kind of the same answer in a narrow sense.